morning, doctors. My name is Mohammed, and this is my co-mate Imad. Today I would like to present our graduation project. It is simply a tracking system it's an indoor tracking system using the radio frequency identifier, the RFID technology. Alright, the question is now, why we chose the RFID, whereas we have many other available technologies such as the Wi-Fi or the infrared. And the bigger question is, why we did not choose the global positioning system, the GPS. We're talking here about tracking, about positioning. The first idea that pops up in any person's mind is normally the GPS, as it is very popular and known. And the GPS today is integrated on many of our cell phones, vehicles, and tablets. Alright, simply, we did not choose the Wi-Fi due to its complexity and high cost in installing the system. And we did not choose the infrared due to have a low reading range, which is not practical, and it requires a line of sight. Finally, let me tell you why we did not choose the GPS. GPS is perfectly known that it is perfectly suitable for the outdoor environment. Talking about the indoor environment, it has lack of accuracy and it gets easily distracted by the environmental impact. Summing it up, researchers and scientists, and that's also according to my personal research, they claim that the RFID technology is considered the best tracking technology due to its easy for installation, and it has a very fine level of accuracy. And above all that, we have an important factor called cost. Regarding the cost, the RFID considered the cheapest type of technology used in an indoor tracking system. Here, let me just quickly demonstrate to you a general overview of the entire system. As you can see here, we have an RFID reader, a host computer, a screen, and a person with a tag. Here, we have the 8-meter range of tag. The RFID gets the information from the tag and sends it to the host computer. The host computer does its calculations and sends their information to the screen. And as we can see here, we have a screen map and a tag tracked on screen. This tag tracked on screen shows us a real-time update every time the person moves. And this RFID reader keeps on updating every 2.3 seconds so that we can exactly know the location of the tag at the current time. Our system can be applied in many different applications. We can actually use it in hospitals to track patients, especially Alzheimer's patients who are physically present but mentally absent. We can also use it in schools or playgrounds to track small children, and we also can use it in safaris or open zoos to track animals with special needs. And we have other many different types of applications which our system can be applied at. And my co-mate Imad will fulfill you with the details of the project. Thank you for your time.
Good morning, doctors. I am Imad Deen, and first of all, I will talk about the block diagram of the entire system. So, in this figure, as we see, we have a room 4 by 6 meter, and there are 24 reference tags distributed in this room, and there are 3 RFID readers installed also in this room. These dotted circles represent the coverage area of each RFID reader. These RFID readers should be connected to the host computer via USB channels, and the function of the host computer is to determine the position of any tag enter this room. This is a simple flow chart will explain how the entire system works. The first step is to store all the reference tags locations. And then 3 readers will read all the received signal strength values of each reference and unknown tags. And then the host computer will determine the nearest reference tag of the unknown tag or of the tracking tag. And then will display the result via graphical user interface GUI. This process should be repeated every 2.3 seconds because our RFID reader read all the tags once every 2.3 seconds. And if the tracking tag moves to another location, its new position should be updated every 2.3 seconds. Then I will talk about the cost of our system. We need 3 RFID readers. Every reader should be able to measure all the received signal strength values. Or every reader, its range should be 8 meters. The cost of every reader will be $50. And we need also 24 reference tags, and 3 active tags should be should be excessive for test the system. Every tag is $20, and we need a host computer. It will be a laptop, so the total cost will be $690. This tables explain the individual task of each of us, me and Muhammad, in this semester. Thank you for your attention.
Okay, thank you very much.
Thank you.
Thank you very much. You are confined with the timing, and I leave the floor for the questions. I have questions myself. Let's start with Dr. Ismail. Dr. Mark. Okay, Mark. Questions?
You mentioned GPS. Is this a duplex or half duplex or a simplex technology?
It's simple, yes, but it's not good for outdoor environments, and that's why we choose RFID technology.
Okay, and where are you going to be stored? How are you considering storing the data that you've gathered?
You mean the tax locations?
Yeah. You showed me a diagram with a
Yes.
computer. So presumably you're going to be gathering positional data. How are you going to store this data?
The reference tax location should be stored in the host computer, because when any other tag will enter this area, the host computer will determine the nearest reference tag of this tracking tag which entered this area. But you mean how the host computer will determine the nearest reference tag?
Yes.
This is the 3 readers will measure the received signal strength of each reference tag, and any tracking tag will enter this area. And then by using the root mean square equation to determine the difference between each received signal strength between reference tag and unknown tag, then we can determine the nearest reference tag by taking the smallest root mean square of the difference between them.
And
now,
okay.
Go ahead.
And how many separate unique devices is your system likely to be able to track in a given space, say like this room?
In this room,
For example.
it will be also 3 RFID readers, and but the reference tags will be more than what we have, because we need accuracy of 0.5 meters, so it will be bigger. But
Can I rephrase his answer, please? Well, we have the ability to track 80 tags as long as our RFID reader have the capability to track or to get 80 tags at the same moment. So we can track 80 persons, 80 assets, anything that we were actually interested to tag.
Yes, thank you for your presentation, Mohammed. In your presentation, you mentioned something about possible applications in a hospital environment, with patient being physically present and mentally absent.
Yes.
Can you please explain what this means?
Well, at a high level, Alzheimer disease, when it goes to a very far level, the patient will almost be mentally absent, and he's physically present, he's alive, but I don't want to really talk about the Alzheimer disease, but some of like without mentioning names, had asked us that the RFID technology is actually a waste of money to install at it. So I replied to him, a person with an Alzheimer's, and he said that instead of using the RFID technology, we all nowadays have cell phones. So you can easily call him and tell him where is your location instead of tracking him using this technology. I replied saying that a person with this disease, with an Alzheimer's disease, he don't have the ability to exactly tell you where is his location at. So we can't use this. So we're actually, we must use this technology in order to track him. I hope if it's clear for you.
Well, not really, but let me ask you why I mentioned this question. I think looking at the overview of the project, there are some very good points. But I think what's missing, if you look at the title, it's an indoor tracking system using RFID. But what is missing is a context to it. Where can it be used? Because it's, at the moment, from what I gathered, it's fairly generic. So perhaps you need to add a context, because otherwise it's really too generic.
Oh, okay, all right. If the hospital example was not really clear for you, can I add the safari or the open zoo example?
No, I think you're slightly missing the point. I think overall, when you look at the project, it's about indoor tracking system using RFID.
Exactly.
What I'm saying is that there needs to be an application, a context whereby you apply this, instead of just saying indoor tracking system. Maybe say indoor tracking system within a particular environment, say a hospital or whatever you choose to do. I think it would add a little bit more focus to the project.
Oh, so you meant that to be more precise on the title, not generalizing it as an indoor tracking system.
Yeah. Not just on the title, but also on the
yes,
obviously.
okay. Yes. Okay.
All right. That's fine. And looking at the report, and also, can you go back to the previous slide, please?
Yes, sure.
Okay, this is the plan of from the start, is it?
Yes, from
Where are you now?
Week 16. We are in the final report editing and we are preparing for our presentation.
So what's the next step now? What's the plan for the next step?
Well, our future work is that we will actually, immediately after this presentation, maybe tomorrow or the day after, we will go meet our supervisor. We had already chosen our RFID reader and the tag. We already chose the product.
Okay. The question is, where is it, the plan?
Oh, you mean the future work? It is there on the report, but unfortunately we hadn't demonstrated in our presentation. But I can tell it to you verbally if you'd like.
I can't. This is just there.
No.
Okay, but these are all kind of areas, but there is no plan. I think we're expecting at this stage a plan on a week-by-week basis, you know, precisely, along with the individual response to this for each. Okay, all right. No more questions. Thank you.
Thank you. Yeah. One more question. Yes.
I have questions myself. Your presentation was very good, except that it lacks the. I know that we told you not to say background, but there must be some other systems in the market that do the same thing. Have you compared these systems to use? No, reading is not enough. I mean, reporting it. Did you compare your system with existing ones and how your system would be different?
Yes. We have a related work, a technology or a system called Spot On. Some researchers had actually done it.
And it is there in the report?
Yes, it is there on the related work chapter. All right, let me just briefly tell you what exactly is.
Instead of the flow chart that was detailed, you could have just mentioned this, that you have done this, and this would take less than a minute in the presentation.
All right.
The second question is, you mentioned that you will be using RMS to determine the nearest RF transmitter or something. But how do you determine where exactly? Because when you determine the distance, it is only a radius, right?
Yes.
So it could be
Actually,
any point in a circle around the nearest one.
Yeah, and that's actually we don't look for determine the exact position.
Now that's very important, because the distance by itself is nothing. Unless you measure the distance between the object or the tag and the three transmitters, or the three readers.
Yes, this is another method technique we put it in the report.
Yeah, I'm referring to your presentation when you said only I use the RMS to just determine the nearest tag or the nearest reader. Right? So yes, I think there is lots of work to be done.
You mean we should work to determine exactly the position of the tag?
You said the accuracy is in terms of
50 centimeters.
yeah. So how would you do this?
However, there's a methodology from Charles.
You mentioned the technique here. You don't have to go through the details of it. That's what I'm saying.
Okay, thank you.
I'm not.
Thank you. And it's my pleasure to have my presentation presented to you. Thank you.